Yes, ma'am. We are live, ma'am. Please start.
Okay, hello everyone. This is our first live session for Carbon Materials and Manufacturing course on NPTEL. I would like to see if there are any questions or if there are any people. Since we are live on YouTube, please post your questions. My teaching assistant Mamta, is she able to see? Mamta?
Yes, I'm able to see
YouTube video and the questions as well.
Yes.
Okay, all right. So just let me know whenever there is any question. I will, before that, just give a brief sort of introduction of what's going on. We are now already on week 9 of our carbon materials course. And we have actually learned a lot of things in all these weeks. So in fact, soon we will be starting with carbon nanomaterials, but as I had promised, we discussed a lot of bulk carbon materials, industrial carbon materials, which includes initially graphite. So we started our discussion with graphite because graphite is the most important industrial carbon material. And that also is the sort of gold standard. I must have said this also in my lectures, that graphite is always our gold standard. We always want all our carbon materials to sort of be like graphite. What does that mean? That means that we want to have a higher crystallinity, because higher crystallinity increases the electrical conductivity, and it also increases or improves the mechanical strength of our carbon materials. So we always want to get more and more graphite-like structure, which is graphitic structure. So graphitic is this term that is used for the type of carbon materials. For as we become more and more graphite-like, we start calling it more and more graphitic material. Although there is also an IUPAC definition, I think in one of the lectures I've discussed that. So there are different terms: graphite, then graphitizing, then graphitic, non-graphitizing, all of these different terms that we have already. So I will not repeat it here because we already have them in the lectures. The idea, however, is that we are always trying to make our carbon material similar to graphite. And for that, what we need to do is we need to keep on increasing the process temperature. So how do we make carbon materials? We make them by, usually in most cases, carbonizing or converting any hydrocarbon materials into carbon, which basically means we need to get rid of all the things that are not carbon in that material. So hydrocarbons will typically have what? Hydrogen, oxygen, nitrogen, sulfur, in some cases halides. So we need to get rid of everything that is not carbon, and then we are left with carbon. That is the process where we sort of keep on heating the material in the absence of oxygen to prevent burning. This process is known as pyrolysis. So we keep on heating the materials. And once we get rid of all the non-carbon atoms, then if we further keep on increasing the temperature, then what happens is these now carbon atoms will come closer and closer. And then as we keep on increasing the temperature, they will become more and more graphite-like. They will become closer to graphite. And that is what we call as more graphitic carbon. But there are also some other types of carbons where the initial structure of polymers is so sort of complicated, polymers or any other heavy hydrocarbon which we use. If the initial structure is very, very complicated and the chains of polymer are, entangled with each other, in that case, irrespective of our final heat treatment temperature, we may never get graphite. So that is yet another type, and that is what we call as non-graphitizing carbon. So these are some of the basic things. And of course, in the course, we have also learned a few manufacturing processes. How do we make anything out of carbon? So this is a carbon materials and manufacturing course. And manufacturing is always this sort of industrial sounding word. A little bit, it always gives the impression of something that is large scale, which is correct. Even when we make nanoscale materials, but in large quantities, we call it often nano manufacturing and so on. Anyway, nano manufacturing is a term that is used for multiple things. But here in this particular course, the idea was to learn how to make structures using carbon, for example, large graphite-based electrodes, or even carbon fibers, or any other composites, and all of these structures which are industrially very relevant. So we have gone through also some of these manufacturing processes. So this discussion session should not be a monologue, and I am hoping that there are some people. Unfortunately, I did not receive too many questions yet. So if anyone is around, I request they post some questions. I will wait for a couple of minutes. Otherwise, I will again start with, the general discussion. Mamta, do you
Swati, yes, we have a question from Chirag Kumar.
Okay, just a second. Actually, yeah, just a minute. Huh? So I will open the YouTube link on a different window. I request they post some questions. Okay, so there is some delay in my response. So this is what I'm going to do. Mamta, can you read out the question?
The question is why graphene is used as construction material?
Construction material. Okay. All right. So this is an interesting question because graphene is not directly used as a construction material. It is, however, mixed in some types of cements or concrete as a reinforcement. Now, what is reinforcement? That is something you've learned already in your composite section. So reinforcement are basically some additives that are mixed inside any matrix. And those matrix materials can be polymers, or they can be concrete, or they can be other, even ceramics and metals and so on. So when graphene is mixed inside a concrete matrix, then what it does, graphene or any other carbon nanomaterial for that matter, or any other nanomaterial also, what these nanomaterials do is they fill the pores of concrete. And that is very important because that increases the strength of the overall concrete. So why we use carbon nanomaterial compared to other nanomaterials? Because they are also light. So they make the material lightweight, and they also fill the pores, and that is how they are used as reinforcements, and we can use them as construction materials. So don't think of using graphene directly for construction purposes. Okay, so now there is, I hope, Chirag, I have answered your question. Okay, now I will go, there's a second question now I see. How to calculate magnification factor in area of carbon fiber formula? In area of carbon fiber formula. Okay, this is a little bit confusing. I understand that you're asking regarding the CFRP course, the lecture. How to calculate magnification factor? You need to be a little bit more specific. In general, these factors are specific to the material. So whatever we buy, we know the magnification factor already. They are very specific to the type of laminates that we have, or the type of fibers that were used for making that particular CFRP. So when we buy them, we already know this value of magnification factor. What we are rather calculating is, when we are drilling a hole or something, accordingly, we are calculating what is the delamination, the area where the delamination took place, and so on. But magnification factor is usually given to you. Okay, that was Suraj and Chirag. Are you guys taking the exam? I saw today there are a lot of people who have registered for the exam. I'm happy to see that, but at the same time, I'm surprised that nobody's asking questions. Also on the platform, the class platform. Chirag, Suraj, are you, have you registered for the exam? Okay, so what is happening here is there is always a little bit delay in YouTube live, when live forecasts. And that is why maybe what I speak, I hear it after some time. So maybe there will be some pauses. Okay, Chirag and Suraj, maybe you should also call some of your friends. In the meantime, tell me which topic interests you more. Then I can give some, some pointers on that topic. So which, basically, when I say which topic, which carbon material you like the most? Nothing? Mamta, if you read something, let me know.
Okay.
Okay, all right. Let's talk a little bit about CFRP. CFRPs are basically carbon fiber reinforced plastics, and these materials have become very, very popular lately, right? So someone talked about graphene, and so it's interesting that these are only two questions. One is related to graphene, one related to CFRPs. I personally, really like non-graphitizing carbons, but nobody really cares about them. So what happens is, what has recently happened is the most common application of carbon has become, or at least industrially in terms of market value and in terms of the volume of carbon that is used, CFRPs or carbon fiber based composite materials have become very, very significant. And just before that, it was graphene. Even now, for many applications, so graphene has its own place because a lot of device applications or a lot of small scale structures and so on, they are even some coating materials and all, the graphene is used, and it's still a very popular material. But in terms of volume, because carbon fibers are like structural materials, so that is why in terms of market and volume and so on, they have become very, very popular. When I say in terms of volume, and when I say also carbon fiber, typically in the industries, or when people commonly speak the term or say the term carbon fiber, that really means carbon fiber reinforced polymers. In some cases, people may even call carbon fiber reinforced carbon, which is a carbon-carbon composite, even that people may call, carbon fiber. So my point here is that nowadays nobody's using only carbon fibers, except for very few filtration applications and all, but they are not large scale. When they say carbon fiber, it is basically the composite material. And these materials are used for a lot of structural applications. Structural means making bodies of automobile, making bodies or fuselage of aircrafts, and then also a lot of spacecraft, so space vehicles and so on. What else? Wind turbine blades. So these are some of the very common applications. Pressure vessels. I'm not even sure if we have discussed all of these things definitely not in detail, because this was a carbon course. Some different courses, maybe I even have some other videos on YouTube. That's where I've discussed these very specific applications. So carbon fiber based composite materials is something that is very interesting and that is the next generation material for all kinds of manufacturing. And in a lot of applications, they have already replaced metals or replaced other traditional materials. The only one issue there is that in high temperature applications, they are not very useful, because carbon fiber reinforced plastic, of course, the plastic itself or the polymer itself will melt at high temperatures or degrade, let's say even above 200, 300 max. But even CFRC or the carbon-carbon composite, even that is not usable for very high temperatures. At least it can go up to say 400, 500, but above that, in the presence of oxygen, it gets oxidized. So if oxygen is not present, then it's all right. But if oxygen is present, then it's an issue. And that is one big challenge. So in fact, if some of you are working in research fields or even in industry, somebody can come up with a material which has some sort of oxidation protection. That is a very interesting work to do, and that will help a lot of other industries where carbon fiber is still not used directly. So yeah, this is one interesting story. Now I need more questions. Chirag and Suraj, you can yourself again ask questions. It's not that one is the limit. Come on, guys, ask something. My last year when we had the same course, there were like so many questions. that it was difficult for me to answer all of them. They were like hopping one out of after the other.
Swati, there is one more question on carbon-based quantum dots. It's just mention carbon-based quantum dots, not a question.
Okay. Who has written this question? And I still somehow it's not updated on my system. Who asked the question? Because I know a couple of students had approached me regarding quantum dots. Although quantum dots, to be honest, is not my personal area of expertise. Quantum dots itself is a sort of a broad topic. So now, since there is no very specialized question, I will just talk about it. In this entire course, I did not really include quantum dots, and that's because they are not really used for large-scale manufacturing purposes. Even the carbon nanomaterials that I have included, some of them you may have already learned, and some will come soon, even diamond-like carbon and so on. So the nanomaterials that I have included are still those which are used, for some structural applications, some large-scale application, or at least their production is taking place at a large scale. Quantum dots is still, quantum dots, first of all, are structures usually 5 nanometer or smaller. So quantum dots of anything can be 5 nanometer or smaller. You can have various nanomaterials, metal-based quantum dots, and so on. Carbon-based quantum dots are also these extremely small sort of particles, but we don't call them particles when they are so small. When several quantum dots, of course, agglomerate and then they make slightly larger structures, then we can call them particles. Now, if you remember from carbon black, we can also have much larger microscale clusters where individual units are 10 to 12 nanometer, but we still then call them cluster or particle, depending upon the size. Anyway, the thing with carbon-based quantum dots is that it's not just one type. There are many different ways of making them. Some of them contain nitrogen. Some of them may also contain impurities and not just carbon. And some of them can be very graphitic. So some of them basically will have no impurities. There's one very simple method of making carbon-based quantum dots, and that is by heating sugar solutions and then adding some in acidic or basic medium. So you can add some acid or you can add some base. Now this is just very, very brief information, but you can find several papers where these kind of methods getting carbon quantum dots from sugar are mentioned. So what is sugar? Basically, it's some sort of hydrocarbon, and from that hydrocarbon, when we heat it, we get rid of a few non-carbon atoms, but also with the treatment of acid, we can get rid of some of the non-carbon atoms. So when we have the influence of both, we can get carbon. Again, some of them are turbostratic, some of them are graphitic, some of them also have fluorophores attached to them, or some of them even have intrinsic fluorescence. So all of these things are, they are used for making different types of devices. That is what I know of carbon quantum dots. I've personally not worked with them. Shiva? There is some noise from Mamta, you see anything else? Okay, Shiva has muted the mic. All right, Mamta, do you see any further questions?
Yes, there is a question. Carbon fiber is also used in 3D printing for making products.
Mm-hmm.
So that is the question.
Okay, so maybe it's a comment, maybe it's a question, but it's correct anyway. Yes, carbon fiber based composites are also 3D printed. There you have to just be careful a little bit that these are not laminate type composites. So we discussed in detail that there are two different types of composites. even when we talk about carbon fiber or we talk about other materials, they can be either laminates. Laminates means these layered structures, and there you are going to use these woven cloth-like structures. And then you have particular weaving or particular braiding. Then you place one on top of another at 45-degree angles and so on. So these are laminates. These are the structural materials. These are the materials which have very high strength, mechanical strength. But you also have the other type of composite where you have short fiber composite. So not just carbon fiber, but you can also make them with carbon nanotubes. And these materials, because see, nanoscale carbon, whether they are nanotubes or even nanoscale fibers, or even not nano but microscale fibers, still it is possible to print them. And yes, so you're correct that this is what we use. We use them for making, for example, things like bone implants or tooth implant. Of course, these are very new materials. Not all of them have, the approvals of medical authorities and so on. But this is definitely going to be soon, approved and in market as well. But yeah, so these are not laminates. The 3D printed ones are short fiber or carbon nanotube based composite materials. In fact, you can also mix tubes or vapor grown fibers in ceramic matrix, and then you can have these bone implants and things like that. Of course, also in polymer matrix. Yeah, so you can do a lot of things with them. All right, anything else? Huh. Did I talk about 3D printing in this course? Maybe not. Maybe see, there are so many manufacturing possibilities with carbon, and it's really hard to cover all of them in one course. But that is why this is more of an introductory thing, 12 weeks. Still, I think you must have learned at least about different types of carbon materials or carbon structures. Like carbon fiber, we call it a material, but as such, it's a carbon structure, right? Similarly, many carbon nanomaterials also, they have a certain structure, certain type at nanoscale, like carbon nanotubes are different from graphene and so on. But we call them materials, and then we make something out of them. We call them manufacturing or fabrication of devices and so on. And basically, these materials are the materials of our current century, or these are the next generation materials. I recently heard someone saying that when we have this we define the civilization based on the materials, right? We say that this was Bronze Age, this was this age, this was that. And now this is the carbon age. So previously, maybe another 10 years back, and we had silicon was the most important material, semiconductor industries. All of you know, I mean, it's not that it's not important, but still very important. But the future belongs to carbon. So even we can call it, a carbon age. So if you're doing this course, I hope that you like the course, and I also hope that you take a lot of things forward. So maybe what I have discussed is based on the current knowledge, but in the future, maybe a lot of new things that you guys can do. This is bone implant and 3D printing, and all these kind of things are very, very, very interesting. Anything else, Mamta?
Yes, we have a question again on quantum dots. Can quantum dots conduct electricity?
Mamta, do you have an answer to that? You have recently started working. See, again, I personally believe that there are different types of quantum dots, and not all of them are conductors, but some of them are. It depends on whether they have fluorophores or not. It depends on whether they contain any nitrogen, any other impurity or not. In most cases, they are definitely not very good conductors. This is my understanding. Mamta, if you have anything to add to it.
Most of the quantum dots are semiconducting, not 100% conductors, but they are semiconducting. This is what I have learned.
Yeah, so that is what we have now. Also, their properties may change when you take an individual quantum dot, or when you sort of take them in bulk. Let's say if you mix them into a polymer and then you print them, then you may also definitely find some differences. But most of them are not good conductors. Semiconductor, as Mamta said, I cannot comment on their band gap or exact semiconductor properties, because personally that is something I'm not aware of. But not good conductors. That's the answer.
Actually, we can tune the band gap based on the size, and based on the surface functional groups, the band gap can be tuned.
Okay, all right. Okay, any questions about bulk carbon? So the large scale manufacturing, large scale carbon. Why do people not work with large scale materials anymore? Why is everybody trying to do nanoscale manufacturing? See, good old fashioned industrial manufacturing is still, carbon is really useful for those purposes. And also now even the new types of carbon materials, carbon fiber and so on, also are used for making airplanes. So there is also a need for people to not just make very small scale devices and always nano micro structures, but also go into making larger structures. Of course, we can have now the knowledge of nanotechnology integrated with these large scale things. So for example, what you can do is you can also reinforce your composite materials with some other nanomaterial. In fact, there are people who are growing carbon nanotubes or attaching carbon nanotubes on top of carbon fibers, which are microscale in diameter. And then you attach carbon nanotubes around them, or you can even grow carbon nanotubes. So use them as CVD substrates, for example. And then these materials are then further used for making composites. So these are also very interesting materials, because there you not only improve the surface properties, you also decrease the weight altogether, and you also, at least that has been reported in a few publications, that you also increase the lifetime of your entire structure much more. These kind of structures have been used, or at least people tried to use them in wind turbine blades, for example. So yeah, you can use these kind of integrate everything and come up with these really fancy materials. So that is already happening. The only thing is you have to also think in terms of recyclability of those materials, which can potentially be a challenge, which is a challenge. But yeah, there are also many people working then in that direction. So yeah, hopefully. Okay. Good. We have had some questions for sure. And it's 30 minutes in the lecture. Let's go for the entire 1 hour. And I know that this is this is like a weekday evening, and many of you are working, so this might be a little bit of an uncomfortable time. But on the other hand, even weekends also people are not happy with. So in general, I had to find some time slot where which is okay for all of us. Chirag, Suraj, all of you are still here or not? Shiva?
Swati, we have a question. Any method to calculate porosity of materials by using optical microscope?
Right. So we will come to this to the lecture. This is, I think, in the last week, where we will discuss porosity measurement techniques. So the most common one is using gas absorption isotherms, and that is something we have discussed in detail. But your question is whether we can use optical microscopy. Now, a lot of people, so it depends on the pore size, right? Optical microscopy has its own limits. You cannot really see nanoscale pores using optical microscopy because of the diffraction of light. Because the whatever is the wavelength of optical light, or whatever light whatever wavelength you're using for that matter, if you go below that, then the sizes, the pore size is below that, then it will be difficult for you to see. Even with that, if you see the photolithography lecture, we have this one formula where you can understand what is the minimum size you can see depending upon the wavelength of light that you're using. So even some pores even larger than the slightly larger than the wavelength, you may not be able to see because of diffraction reasons and so on. However, if you have large enough pores, then what you can do is you can take just an optical image, micrograph image, like in microscope, optical micrograph we'll call it. So try to get it as with as much magnification as you can, not the mobile phone image, right? So you take an image in the optical microscope and then there are various software available. Some of them are also freely available online. There is something called ImageJ. This software, a lot of my students are also using. So this is a free software. You can, then it has a lot of options. Now I'll not go into the details exactly of the software, but there are a lot of options there, and you can do the calculation of surface area, porosity, and so on. Other than optical microscopy, if you really want to take the 3D image, if you want to see inside the structure and so on, in that case, you can perform X-ray tomography. You can also perform MRI. Of course, it will be a very expensive technique for just the measurement of porosity, but the advantage there is that these techniques are non-destructive, and you can have different slices. So if you have a block, let's say this is my mobile phone, let's say this is a block, then in that case you get sort of different slices. If you have seen the brain MRI or something, same concept. And then you can use a lot of software, any software for that matter. There are many image processing software. And then you can reconstruct the images. You can then calculate porosity and so on. Again, limits of MRI, these MRI as well as X-ray tomography are not, so you still only will be able to see micro scale pores, micrometer scale pores, which are called macro pores, which are not called micro pores or nanoscale pores. You know that. I don't know if I have discussed it yet, maybe in the activated carbon lecture, or maybe I will discuss it when we talk about the surface area analysis. Anyway, the point is very, very small pores. If you want to see, you have to perform some other analyses like gas absorption, isotherms, which is a cool technique, and it's a very simple one as well. Yeah, so I think it's in the week 11 or week 12, you will learn about it. Okay. I'm thinking what can be discussed right now. Anybody interested in activated carbons? Now, since we were talking about porosity. Okay, I'll tell you a little bit about activated carbons anyway. So the porosity they have is this fractal type porosity. What is fractal? Fractal means if you have something and then the exact same shape but smaller, the exact same shape but even smaller, even smaller, even smaller. That is sort of this branched structures are called fractals. There are many other examples also. Fractal structures are used in artwork and so on. There are a lot of things. You just search for it online. You'll find a lot of fractal structures. I think in I also described it mathematically a little bit in the activated carbon lecture. So these kind of structures, basically the porosity can go down all the way to a couple of nanometers, even 2 nanometers, even down to 1 nanometer. So you have just these repeating structures, repeating units down to very, very, very small sizes. So in that case, you can actually have pores that are still accessible. So they're not closed pores, they are accessible, but they're extremely small. And that is the reason activated carbons have very, very good absorption. Absorption is on the surface and absorption is inside. They have very, very good absorption because even their, the pores that can be reached by gases or can be reached by liquids and so on, even they go deep inside, and they have these multiple sort of hierarchical structures. So you have bigger ones, and then smaller, smaller, and so on. And some of them also, of course, are also closed pores. They are deep inside. They're not on the surface. So what we do is we crush the material. We somehow make powder, small particles, and so on, so that we increase the surface area and we can reach more and more pores. Now, what will be the advantage of something like this? Well, one advantage, of course, is very standard applications like water filtration. So very common application. And that is something not just used for your house drinking water purposes, but much more importantly for industrial wastewater treatment. Because now in our country, many other countries in the world, there is zero waste water policy. What does that mean? That means that you cannot throw just water, after any chemical treatment, anything. No industry can just throw water into the river or into the soil or anywhere. So we need to make sure that water is 100% clean, and for that we need inexpensive options. And activated carbons can often be made by waste materials and inexpensive precursors. So in that case, these are very good options. What is also very interesting is that not only that you can make these structures, but you can make the water filters. You can also again clean or reuse the carbon, which was in the which was once it was used for water filtration purposes. You can again heat it, get rid of whatever impurities are stuck to it, and then you can reuse it, heat it, also sometimes chemically treat it, and so on. So these are very interesting materials, very inexpensive and very interesting. Yeah, and they also activated carbon is a big industry all over the world, and in India also there are a lot of plants where we make activated carbon. This is a big industry, and increasing the porosity, very minor details even of tuning surface properties and so on. All of that is very interesting and very useful for anybody who's doing this course for applying for industries. By the way, one thing I don't know if it was announced or not. This course, carbon materials and manufacturing, is also certified by the Indian Carbon Society, and it is recognized by the industries, which means that if you get the certificate and you have the logo of Indian Carbon Society on it, and also it is recognized, then basically it will, if you want to apply for a job related to carbon or carbon-based manufacturing, this will definitely help you. So this is a proof that you know carbon. No other questions, Mamta?
There is a comment.
Okay.
Which goes, I hope in future carbon fiber materials reduce magnesium-based aluminum alloys for making automotive frame.
Yes. So what is the name of the person who asked?
Vishwajit.
Okay, Vishwajit. So this is something I was very recently reading, the entire automobile thing, and the fact that, what is the fraction of the body weight of the automobile and what is the fraction of engine, what is, different parts and interiors and so on. Very interesting and very new topic. Yes, we have initially, so this is the history. Initially we used steel, and then we went into, maybe you know the history, but I'm telling this for everybody. And then from steel, we moved on to aluminum and magnesium-based alloys, right? Now, these materials are good. They are lightweight, because in decreasing the weight of the vehicle is what everybody wants. Why? Because that makes it more fuel efficient, right? So that is even in the guidelines and all these things, the type of engines we have, Euro 3, Euro 4, whatever, all these things. They want to have the cars that are more fuel efficient, which means the body weight of the car should be, or any vehicle should be, reduced. Okay, so we moved from steel to aluminum, magnesium. Now the point is, there are a couple of problems with that. Number one, there is corrosion related issues. Even the manufacturability in some cases is an issue. So these were the challenges, and now carbon fiber, people were working on these things already. They were trying to improve the manufacturability of magnesium, or they were, so trying different contents for making the alloys and so on. And suddenly carbon fiber came into picture as a new material. So which has indeed replaced quite a few things, which so what you're saying that you hope in the future it will completely replace, definitely it has already started replacing a lot of things that are made of metals and alloys. But certain parts, again, high temperature options, they high temperature parts, or even the engine, the internal, the ICE and things like that, they need to be made of steel still. And but aluminum magnesium can potentially be reduced, can be completely replaced. One issue, however, is that the recyclability. I'm personally working in this direction, and I'm personally very much interested. In fact, that was also the reason I was reading this, that metals can be reused, but that is not the case with carbon fiber. What we can do is we can remove the epoxy or the whatever is the resin outside. We can separate them, separate the two components of a structure. But often what happens, especially nowadays in these hybrid electric vehicles, people are also using carbon fiber based body as structural, or what they call massless battery. Okay, so now this if the body itself is used as the battery, that will make the car much more efficient, but then it even poses a bigger challenge when it comes to the recyclability, because in these massless batteries what they're using is, so in very, very simple terms, the carbon fiber part is your one electrode, and in most cases negative electrode, and the resin is your electrolyte. Okay, and then there is another electrode. So the resin then has to be some sort of advanced polymer. Then often these carbon fibers are coated with some sort of lithium materials, because these are lithium ion batteries. And so the entire structure becomes very complicated. So it's not just carbon fiber anymore, which makes its recyclability even more complicated. And definitely it should not be just discarded, because cars, initially it's fine, but they have a lifetime. Maybe your car will, even if the car does not get damaged, after 10 years, 20 years, people just for fun, they want to change their car, right? Nobody wants to have a car for 3 generations in the family. So yeah, recyclability is something that needs to be, but you're right. And I think that will happen very soon, that a lot of, even in India, some latest cars, I don't know, Tata Nexon, what is the name? I don't know, Nexon, Maruti Suzuki, also one model. These models have at least carbon fiber interiors, if not the outer body, but interiors are already made of, at least some part of interiors are made of carbon fiber.
Yes, we have a question asked by Vinayak. What are carbon nanotubes?
What are carbon nanotubes? Okay, these are nanoscale structures which are tube-like, right? So you just take a paper and fold it, roll it, then what do you have? You have a tube. Now this is, you will say that I know that, right? How do we get carbon nanotubes? Where do they come from? How do we grow them? Here is what happens. If you take any iron nanoparticle, okay, and you place it at high temperature in an environment where there is some carbon species, atomic carbon species, or a smaller, even aromatic species, but very, very small, some carbon fragment are present, then what will they do? They start to deposit onto your iron nanoparticle and start growing like a tube. In some cases, depending upon various factors, including the type of carbon species, as well as the type of catalyst, as well as the size of the nanoparticle, sometimes you will get a single wall, sometimes you will get a lot of walls, so like concentric cylinders. So then you call them single-walled carbon nanotubes or multi-walled carbon nanotubes. Now, this happens. It's not that carbon nanotubes are very new materials. It's just that we have started using them in technological applications only since the 90s. But before that also, these kind of structures were observed. For example, in near those furnaces where people use, where people process iron. So if during iron processing, of course, there will be some iron particles, small ones, big ones, even sometimes iron walls. And there will also be a lot of carbon. Where will that carbon, vapor phase carbon, come from? Well, you will have a lot of gases, because often in these big furnaces, you will burn some sort of fuel. So there will be some hydrocarbon burning. And because of that, there will be some carbon species, small carbon species being generated. So they can get deposited onto these iron nanoparticles. Now, this is the very standard method. Now, this is what we also do with when we call it chemical vapor deposition or CVD. This is what we do. We take a substrate, put carbon and iron nanoparticles on top of it. Then we have methane or acetylene or some source of carbon, some hydrocarbon gas, for example, which can crack at a high temperature. So we can increase the temperature of our substrate, for example, and then we can grow these carbon nanotubes. Okay. But we can also then go into more, more complicated manufacturing processes. People have developed not just iron, but other catalysts, which catalyst will give you single walled, which will give you multi-walled tubes and so on. And also in some cases, people have been able to grow them very long. In some cases, people have grown them as forests. So these are basically, by changing the parameters slightly, we can get different, we can have different growth patterns in carbon nanotubes, let's call it. What do we use them for? We can use them for a lot of things, including device applications. So now you can see these tubes are so small, one walls or a couple of walls up to 10, let's say. And they are pretty much made by this bottom-up process. Bottom-up means they're growing, right? So the carbon species is depositing in very, very, very small amounts, almost atom by atom. In that case, there is very little possibility of having defects. There are defects when you have forest, like a lot of carbon nanotubes, and we have, multi-wall, then there are defects. But in general, compared to, say, carbon fibers or anything that is made by the top-down processes, compared to them, tubes have like very, very few defects. And that is why they have very high electrical conductivity. Now you can use these tubes for making a lot of electronic devices. They are very light because they are hollow, they are tubes, right? So they are very light. They also have, because of high graphitic content or less defects, they also have very good mechanical strength. So they can be used for a lot of purposes. So not just for their electrical properties, they are also used for their mechanical properties. They're also used as a reinforcement in various composite materials. So there are a number of applications of carbon nanotubes. So I hope I have answered your question. If you want to know anything more about it. So this was like the simplest application of carbon nanotubes. Do read about these NM notations and all these things that I have discussed, because it's interesting.
Swati, we have one more question from Vinayak.
Mm-hmm.
Is there any substitute material for wind turbine blades?
Sorry, what is the substitute material? What is the question again?
Is there any substitute material for wind turbine blades?
Substitute. So I thought this is a substitute of what? So right now, what is used in most of the wind turbines, which are between 1 megawatt and 3 megawatt, we are using typically fiberglass. What is fiberglass? That is glass fiber reinforced plastic. So you are, I think, asking for a substitute for fiberglass, and the answer is carbon fiber. And why do we use that? The current glass fiber based the turbines, they cannot be too big. So up to 45-50 meters, you use fiberglass. But if you want to get even larger structures, in that case, you need the material which has a higher stiffness and which is, if possible, lighter. So there, these, the failure mechanism, or especially the mechanical failure, becomes very important, strain to failure mechanism and so on. So right now, people are using carbon fibers, and there have been, some very large wind turbines which go beyond 3 megawatt. Their carbon fiber has already been used, but the point is, right now the technology is very expensive. Two things. There are two reasons why people has not become as common or as popular as it was expected. One thing is, of course, the cost of the entire process. You know that carbon fibers themselves are very expensive because we use polyacrylonitrile, which is a very expensive precursor. Then we also heat them to very high temperatures, especially if we want to get good stiffness and so on. So that's an expensive process, expensive material. So that is one challenge for sure. But the second challenge is also of recyclability. Glass fibers are relatively easy because glass can melt and you can then reuse it. Relatively easy to recycle it. But in principle, carbon fiber based blades are already in existence. So that is definitely the answer to your question. And one more important thing here is that now we are generally the standard turbines are producing 3 megawatt, but we will move to we definitely everybody wants to have 5 megawatt or higher capacity wind turbines. So in that case, we will definitely need to look for a lighter material. In some cases, also people are using, especially in the, I don't know if you are aware of the structure of the wind turbine blade. So you also have some where you have the non-load bearing parts, you have these sandwich layers, sandwich kind of structures. There, people are using combinations of carbon fiber and glass fiber. So they're not completely getting rid of the fiber, glass fiber yet because of the cost issues and so on, but sandwich layers. So you have one layer of carbon fiber and one of glass fiber, and also some hybrid structures then in that case. They also, I read a paper where they use carbon nanotube reinforced carbon fiber reinforced plastic. So basically, there is also some further nanoscale reinforcement of the CFRP that provides much improved lifetime. But again, cost is an issue there. Yeah, these materials are right now, the technology is expensive. Yeah. Okay. So wind turbine and automobile, these both were the applications of carbon fiber reinforced plastics. Pressure vessels is also one very similar example. What else? I was thinking of one more thing. Yeah, I don't know, I forgot. Spacecraft, of course, is another application, but there we have CFRC rather than CFRP. Yeah. We can also use carbon nanotube reinforced just directly materials for various applications, but there we will not have the laminates, so we'll not have that strength there. Yeah. In fact, this also becomes very interesting when it comes to cars, automobiles, somebody was asking. Because if we want to use the structural battery, if we want to use a car body itself as a battery and ultimately connected to the solar energy and so on, in that case, it becomes the materials become very important, right? So the carbon has to be good conductor of electricity, which means you have to have expensive carbon fiber. And more than that, and what interests me more is the polymer matrix, because now we want to use it as an electrolyte. So that material then has to be functional, basically. And there have been different things that people use. There have been even gel-like materials that people use, but there was some compromise with the mechanical properties. Then there have been different types of polymers that people have used, and each one of them presented sort of different challenges. And that is a very active research area also. That is, of course, another, I don't know, 10, 20 years, we are going to completely move to hybrid and electric vehicles, not just in India, all over the world. So structural batteries and massless batteries are very, very important, and they are not possible with glass fiber reinforced plastics or other types of materials. Why? Because carbon fiber is already electrically conductive. Glass fiber is not electrically conductive. Although in these structural batteries, they use separators that are made of glass. But in principle, carbon and carbon fiber, carbon-based materials are already so well known for their electrochemical applications that we don't have to even do too much research. So that's a very upcoming sort of research field. Okay. So good. I'm happy that there were a lot of questions already. We have 5 more minutes to go. So if you have one last question, you can ask. And please use the platform, the forum more often, because I never find any questions. I mean, sometimes I get confused if I'm doing something wrong, if my system working or not, because nobody's asking any questions. In the beginning, people asked, but then somehow they stopped asking. The fact that so many people have registered for the exam, that means people are interested. And today you're asking so many questions, which are also for me very interesting. So if you keep on asking questions on the forum, that will help me. That will also help me understand, what is it that you guys want to learn, because sometimes I don't know if I'm just speaking and it doesn't make any sense to anybody. Mamta, do you see anything else now? I think we are almost done.
No more questions.
Okay, no further questions. I will just wait anyway for a couple of minutes. Maybe I will summarize a few things that I have spoken. So we discussed today a lot of things related to carbon fiber reinforced polymers. And we also discussed a few things about carbon nanomaterials like graphene and carbon nanotubes. So nanomaterials are used for completely different purposes, and composites are used for different, carbon fibers are used for different applications, specifically the laminate type carbon fibers. But all of these are large scale applications that we discussed. We have not discussed too many devices and so on. That also in this course, I have not gone too much into the details, because, that can make a different course in itself. And this course was mainly, my focus was industrial carbon materials. We will be talking a little bit about the characterization techniques. So maybe this is something I was also struggling. Should I have characterization techniques in the beginning of the course or towards the end of the course? Because that do help you understand the material better. But on the other hand, I kept on making lectures for one carbon material after the other, and the good time never came for characterization techniques. So hopefully now towards the end of the course, actually we have already done 9 weeks, so it's not too much time left. We will soon be discussing characterization techniques, which will include crystallography as well as your surface area measurement, these kind of techniques, also electron microscopy as well. So I hope you enjoy the rest of the course. And if there are any further questions, I request you to post them online on the class course platform. And good luck with your exams. And if you also want to ask me any questions separately, you can check my email address on IIT Mandi webpage, and you can write an email to me. So I will now leave the meeting. I hope this is okay for the NPTEL team as well. Acha, okay, I don't think anybody's there. So I will leave the meeting. See you guys.